Today we're going to talk about ellipses, and before we do that, let's just do a quick review of the formulas. Let's see what you remember from the last couple of days. What is the equation of a parabola? The horizontal parabola is x minus h, because it would be basically x equals 1 over 4p y minus k squared. Whereas the vertical parabola, which means it opens up and down, and on the y-axis is y minus k equals 1 over 4p times x minus h squared. And again, remember, if it's horizontal, it'll open right or left. If it opens right, we're adding to the h for our focus and subtracting it from it for our directrix. If it opens left, our focus would be to the left, so we subtract. Our directrix would be to the right, so you add. Again, a vertical parabola would open up or down. So if I'm opening up or down, my focus when it opens up would be above the vertex, so I'm going to add to it, and then I would subtract for the directrix. If I'm opening down, my focus would be inside the parabola going down, so I would subtract, and it would be above, so I would add to the k value. Yesterday you studied the circle. The equation of a circle is x minus h squared plus y minus k squared equals the radius squared. hk is the center, and r is the radius. You should have those on your graphic organizer for conics. Today we're going to add to the equations with the ellipses. So, an ellipse, by definition, is the set of all points created by the sum of the distance of the focal radii. You're going to add the two focal radii together to get an ellipse. A focal radius is the segment joining a focus and a point on the ellipse. Now I know you maybe don't have that written down yet, but just hold on. I want to show it to you so that you can see what's happening. This purple shape is my ellipse. Point A here and point C here are my foci. 0, 0 right now is my center. So since C is a focus and so is A, if I go to point D, which is on the parabola, and D to C, these two become focal radii. I also have a point B on the parabola. So AB and BC are focal radii. I also have a point E on the parabola. AE and EC are focal radii. Same with point G. CG and GA are focal radii. And likewise AF and FC. I have many focal radii there. And what I want to prove to you is that the sum of them is always equivalent. Notice here, from A to B and B to C is the same as AD plus DC, as AE plus EC, as FC plus AF, as GA plus GC. As long as that sum is consistent, you will form this purple ellipse. So now, let's take a look at that a little closer. Here, I have made my ellipse red. These two yellow points would be my foci. They are the fixed points that create the actual ellipse. The red point in the middle, so to speak, is the center. That would be my HK when I get to my equations. That will be HK. Now on an ellipse, since it spreads elongated either vertically or horizontally, where it spreads the most elongated is called the major axis. So my black axis is my major axis. It is the axis of symmetry that is most elongated. My minor axis then is the other axis where it is not as elongated. So knowing that, let's look at the equations of either a vertically elongated or a horizontally elongated ellipse. First, we're going to look at the vertical, which is what I had there before. The equation of a vertical ellipse is x minus h squared over b squared plus y minus k squared over a squared equals 1. Now recall from before, HK is the center point. Right here. The distance from the center to a point on the ellipse, which they will call a major vertex, is A. From the center on the minor axis, which they call a covertex, is B. And since I add here, when I am forming my ellipse, the sum of the focal radii, to find the focus, I will subtract the square of A minus B, and it should equal C squared, where C is the distance from the center to the focus. Again, since I added to form the ellipse, to find the focus, I will subtract the squares. Notice that this is elongated on the y-axis is major. So notice A is under the y. So now let's look at the horizontal. Same process, only my ellipse is elongated along the x-axis. So we are going to change the equation by putting the a squared under the x. And the b squared would then be under the y, where a is major to the vertices and b is minor to the covertices. All right, get your graph paper and let's try this ellipse. 4x squared plus 25y squared equals 100. And it also says draw it and identify the foci. So first of all, to draw it, it needed to be x minus h squared over a squared or b squared and y minus k squared over ab or b squared. So in order, and it always equaled 1. In order to get this to equal 1, I would need to divide by 100. So I need to divide every term by 100, so it will equal 1. If I do that, I get x squared over 25 plus y squared over 4 equals 1. Now it is in the elliptical standard form. So in the ellipse, we need to first identify which is our major axis and which is our minor axis. Since a squared, the larger number, is under x, it is major to the x-axis. It is horizontal. when it is elongated. So this 4 would be b squared. So if a squared is 25, what would a be? Square root both sides, and you get a is plus or minus 5. My center is x minus 0 and y minus 0. So my center is 0, 0. So let's plot 0, 0. A is on the major axis, it's on the x, it goes horizontally 5 units to the right and 5 units to the left of this center. So 5 to the right, 1, 2, 3, 4, 5, and 5 to the left, 1, 2, 3, 4, 5. That makes my vertices at 5, 0, and negative 5, 0. To get my co-vertices, I would use my b squared. B squared equals 4. So what would b be? Square root both sides. b equals plus or minus 2. That is plus or minus 2 off of the center. Since my major axis was x, my minor will be y. So I must move up and down 2. Up 2, down 2. That makes my co-vertices at 0, 2 and 0, negative 2. Now you should be able to draw an ellipse. Now the only thing missing are my foci. So remember, since I added here, I am going to subtract to find my foci. So c squared will equal a squared minus b squared. C is the distance to the focus. So we want to keep that, c squared. A squared. A squared was 25. Minus b squared. B squared was 4. So c squared equals 21. So if I square root both those, c equals plus or minus the square root of 21. So I must go plus or minus the square root of 21 off of my center on the major axis. So if I'm at 0, 0, let's see, square root 25 is 4. So this is a little bit less than 4. So my foci should be here at 4 point and negative 4 point. So my foci are at 0, square root 21, and 0, negative square root 21. All right, let's give you a chance to try this one. 16x squared plus 4y squared equals 16. First you want it to equal 1. So we will divide everything by 16. So I have x squared over 1 plus y squared over 4 equals 1. What is my major axis? What is a squared? A squared should be the bigger number, so a squared is under my y, and b squared is under my x. So that makes my major axes y. It is a vertical, elongated ellipse. So my center, x minus 0, y minus 0. 0, 0. So plot your 0, 0. A squared is 4. So that makes a plus or minus 2. So since my major axis was y, that means I'm moving up and down. up and down 2 from the center. Up 2, down 2. My vertices are 0, 2, 0, negative 2. B squared is 1. So that makes B plus or minus 1. Since my major axis was y, my minor axis will be x. So I will move plus or minus 1 horizontally from my center. Plus 1, minus 1. So my co-vertices are 1, 0, negative 1, 0. And I should be able to draw my ellipse. Now all I need are my foci. So that is c squared equals a squared minus b squared. Since here I added, c squared equals a squared was 4 minus b squared is 1. C squared equals 3. Square root it. C equals plus or minus the square root of 3. Since my major axis was y, my foci must also be on the y. I must move plus or minus square root 3 units up and down from my center. That would be square root of 4 is 2, so almost 2 units. Not quite 2, not quite 2. So that makes my foci 0, 0 square root 3 and 0 negative square root 3. Now, let's see if you can just write the equation if I give you pieces. It says this ellipse will have its center at 0, 0. So h is 0 and k is 0. My vertex is 0, 5. And my co-vertices are 4, 0. So let's see. The general equation is x minus h squared plus y minus k squared equals 1. Over either a squared or b squared, depending which is major. So let's see. I draw myself a little graph over here just so I can see what's happening. Here's my center, 0, 0. Vertex at 0, 5. There's one of my vertices. So this distance is A. That distance is 5. That is A. And my co-vertices are 4, 0. 1, 2, 3, 4. This distance is B. So B is 4. So if I need to, I can dot my ellipse. So from that equation, since A is bigger than B, it will be elongated vertically. So actually, A squared should be under the Y, and B squared should be under the X in this case. So this equation will be x minus 0, which is x squared, plus y minus 0, which is y squared, equals 1, over b squared. B was 4, so this will be 4 squared. A was 5, so this will be 5 squared. So that gives me x squared over 16 plus y squared over 25 equals 1. There's my equation to A. So part B. This time, my vertices, I only get one vertex. Whoops. Are negative 6, 0. But this time I have my foci at 3, 0. So again, I'm going to jot a little sketch. 0, 0 is my center. Negative 6, 0. Will be over here. We're just going to put it here and write negative 6, 0 because it's getting too close to the edge. So this distance is A, since it's my vertices. And A is 6. My focus is 3, 0. So this distance is B. Nope. It's my focus, not my vertex. Not my co-vertex. So this distance is C. So C is 3. I do not have B. But since it's major, because I had vertices to the x-axis, my ellipse will be elongated vertically. Okay. So since my ellipse will be elongated horizontally. So now that means A squared will be under the x and B squared will be under the y. So x minus h squared over A squared plus y minus k squared over B squared equals 1. So x minus 0 squared is x squared over A is 6, that would be 6 squared, plus y minus 0 is y squared over B squared, we don't have, equals 1. So this is going to take just a teeny bit more work. I know c squared equals a squared minus b squared because here they're plussed. So c was 3. So this will be 3 squared equals a was 6 squared minus b squared. So this is 9 equals 36 minus b squared. Subtract 36. Negative 27 equals negative b squared. Divide by the negative. B squared equals 27. What do you need in your equation? B squared. Let's put that in there. So I have x squared over 36 plus y squared over 27 equals 1. And there's my equation for B. Okay. I want to show you a practical use of ellipses. At an amusement park, they have built an elliptical garden. Excuse me. The garden is 32 feet long and 14 feet wide. So I'm just going to draw myself 32 feet long. So my ellipse would be like this. If it is 32 feet long, and this is my center, this much would be 16. And if it's 14 feet wide, this much would be 14. So my center is 0, 0, so that part's going to be x. It's elongated on the y. So it's going to be x squared plus y squared equals 1. Elongated on the y, a is 16. This should be 16 squared. B is 14. This should be, oh no, the whole width is 14. So B should be 7. 7 squared. So x squared over 49 plus y squared over, what's 16 squared? Okay, so there's our general equation. Of our elliptical garden. Now, the area of the ellipse, area of a circle, is a equals pi r squared. But your radius is equivalent to make a circle from here to here as it is from here to here. So it should make sense that it's going to be times AB, because my radii are longer than they are in a circle. So let's find the area of this ellipse. The area equals pi times A is 16 times B is 7. 16 times 7 is 112 pi. Feet squared. And if you want to approximate that, times 3.14, it's approximately 351.68 square feet. Exactly 112, approximately 351.68. All right, now I'd like you to take a few minutes and try these. Given the equation, we are to find the vertices, covertices, and foci of each ellipse. So in this first one, which axis is major? You should say x because it has the bigger number under it. So that becomes a squared, and the 36 is b squared. So to find the vertices, since it's major to x, they're going to be on my x-axis. So since a squared is 144, a will be plus or minus 12 off of my center 0, 0 on the x. So I'll be adding and subtracting 12 from the x value. That will bring me to 12, 0 and negative 12, 0. B squared is 36, so B is plus or minus 6. That is on the minor axis, which should be the y. So y is vertical, so I will be adding and subtracting 6 from my y value. So my covertices are 0 plus 6 is 6, and 0 minus 6 is negative 6. Now my foci come from c squared equals a squared minus b squared. So c squared equals a squared was 144 minus b squared was 36. That means c squared equals 108. Square root both sides. Let's see. That is 9 times 12. 3 times 3 times 4 times 3. So that would be 3 times 2 squared roots of 3. So C is plus or minus 6 square roots of 3. So my foci we'll have to go on the major axis, and since x value of the center, HK, was 0, 0, I have to go 6 square roots of 3 right, and 6 square roots of 3 left. Okay, you try the next one. First of all, I'm going to put this over 1. Major axis is y. A squared is 9, b squared is 1. So a is plus or minus 3, b is plus or minus 1. Since it's major to y, I will be moving up and down. My center is 0, 0. Up and down will affect the y. So my vertices are at 0, 3, and 0, negative 3. Co-vertices will affect the x. Since x is 0, I will go 1 to the right and 1 to the left. That's 1, 0, negative 1, 0. Foci, again, I have to do my c squared equals a squared minus b squared. So c squared equals a squared 9 minus b squared 1. C squared equals 8. Square root it. C equals plus or minus 2 square roots of 2. That's 2 square roots of 2 on the y, above 0 and below 0. So that brings my foci to 0, 2 square roots of 2, and 0, negative 2 square roots of 2. You can pause and work on this assignment. After about 15 minutes of working, I want you to focus back in and turn off the pause, because I'm going to move all of these ellipses off of 0, 0, and I want you to do that as well before you leave today. So if I move off of 0, 0, I need to find my new center. So this ellipse has foci at 4, 2, and 4, negative 6. So I'm just going to jot myself a little graph. 4, 2, that's a focus. And 4, negative 6 is another focus. So my vertex should be halfway between those two. So let's count how many spaces we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So halfway between will be 5 spaces off. 1, 2, 3, 4, 5. So right here will be my center. So that makes my center negative 1, 2. Since foci are on the major axis, my major axis is horizontal, so it'll act like x. So again, my equation will be x minus h squared plus y minus k squared equals 1. Major to the x, so that's my a squared. Minor to the y, so that's my b squared. So far, I have this horizontal distance of c. So this distance is 5. The other piece of information I have says the vertices are at 4, 4, and 4, negative 8. So let's go back here. 4, 4. And 4, negative 8. Oh, I have this drawn wrong. 4, 2, and it should have been 4, negative 6. So we got to change all this. 4, 2, and 4, negative 6. 1, 2, 3, 4, 5 would be here for my focus. So I have 1, 2, 3, 4, 5, 6, 7, 8 to my focus. So halfway between there would be 4 steps. So here'd be 1, 2, 3, 4 would be my center. So my center is at 4, negative 2. And that makes my C value this. 1, 2, 3, 4. So C is 4. So my A value needed to be, I'm going to put it down here, right here. That is 4, 5, 6. So A is 6. Which means x minus h, my center is 4, squared over a squared. A is 16. Or excuse me, a is 6. So it would be 6 squared. Plus y minus k. K was negative 2 squared. Over b squared I don't have. I still need to find that. I do know that c squared equals a squared plus b squared. So c was 4. So 4 squared equals a was 6. 6 squared plus b squared. And that's not plus. That should be minus. Because here I plus, so here I minus. So 16 equals 36 minus b squared. Subtract 36. Negative 20 equals negative b squared. So b squared equals 20. So I can put a 20 in here. And I can replace this 6 squared with a 36. And I have my equation. This negative negative I can make a positive. Okay. Now let's try graphing one, and then you can go back to work and work on adding those in there. Graphing it and finding the foci. Okay. So first let's find our center. H, K. Has to be in the x minus form. So this is a plus 3, so it would be negative 3. And this has to be in the y minus, and it is. Negative 3, 2 is my center. So let's plot negative 3, 2 as your center. What is your major axis? Relative to A. This is A squared. This is B squared under my X. So it's going to be horizontal. So A is plus or minus 5 off of the X value, since the X value goes horizontal. So I must go plus or minus 5 off of this negative 3. So that brings me to vertices negative 3 plus 5 is 2, 2. Negative 3 minus 5 is negative 8, 2. So let's count that out. 5 to the right, 1, 2, 3, 4, 5, and that is 2, 2. 5 to the left, 1, 2, 3, 4, 5, and that is negative 8, 2. B squared is 9, so B is plus or minus 3. Since that is vertical, I must go plus or minus 3 above my y value. Above my y value. My y is 2. Plus 3 makes it 5. So that makes my co-vertices at negative 3, 5. And my 2 minus 3 is negative 1. Negative 3, negative 1. Let's plot that and see. If I go 3 above, 2, 3, that is 3, 5. And if I go 3 below, 1, 2, 3, that is negative 3, negative 1. And now I should be able to generate an ellipse. The only thing missing are the foci. So I know that c squared equals a squared minus b squared. So c squared will equal a squared was 25 minus b squared is 9. C squared will equal 16. Square root it. C will equal plus or minus 4. Plus or minus 4 off of the major axis horizontal. Plus or minus 4 on the x value h of my center. So plus 4 brings me to negative 3. Plus 4 is 1, 2 for my focus. And negative 3 minus 4 is negative 7, 2. Now let's see if we count that from our center. We go plus 4, 1, 2, 3, 4 for my focus. And left 4, 1, 2, 3, 4. Does bring me to negative 7, 2 and 1, 2. All right. I would like for you to continue working on your ellipses. Make sure you do the problems that are off of the center as well on your assignment.